as I told, when we go with flow control, we will be looking at how we can regulate the traffic between source and destination. For that, we will be looking at sliding window protocol, and we have some issue with sliding window protocol, which is called as silly window syndrome. These are the things we will be looking. So, as we discussed with respect to even data link layer, sliding window, it will be something like this, wherein we have continuous sequence numbers here, like you can see here n-1, n+1, like that we have given numbering here. And what happens in this one is, whatever the packets which are there within this boundary, all those sequence numbered packets we can send without waiting for acknowledgement. So that is a rule. Okay. So you can see here we can send anything from n to m. Okay, till this point we will be able to send. Whenever we get an acknowledgement, what happens is like let us say for n we have received acknowledgement. So we have to remove that one from buffer, right? So this particular window from here, it shifts to this particular position. This is considered to be closing up window. Okay, whenever you receive an acknowledgement for any outstanding segment, we will be closing the window, and we will be removing this particular segment, and we will be moving to next one. And whenever we get an advertisement regarding window size, etc., we will be moving this particular window this side. That is considered to be opening of the window. Okay. So, for example, let us say we have 10 numbers within sliding window, and I got acknowledgement for 5 of my segment which I have transmitted previously, and next receiver window size is also 10. Then we will be shifting 5 positions. Okay. So that is called opening. And always you remember, so let us say previously the receiver told some window size, and we kept a deadline till m we can transmit, like that we can. In future, whenever receiver is advertising about window size, it should not advertise a number which makes us move our window size this side. Okay. So for example, previously you have told advertise receiver window size is 10. So I said till m packet I will be able to transmit. But later you said I have, let us say, 5 window size, which is making us move 5 positions this side, then it is not allowed, which is called shrinking. Shrinking of window is not allowed in TCP. Okay. So this is what we need to consider. We will see that how we can overcome that one. Okay. So a sliding window is used to make transmission more efficient, as well as to control the flow of data so that the destination does not become overwhelmed with data. So that is what we are trying to say here is whenever we are trying to use sliding window protocol, we are making sure whatever the data we are sending to the receiver, that is not discarded. Okay, that is not discarded. In a sense, whenever you are sending more amount of data and the receiver has no capacity to store that particular data, we will end up discarding the packets. Okay, using this sliding window protocol, we are making sure we are not going to face such situation. That is what we are saying here. Okay, and one more thing which we need to consider here: what is the window size? How we are going to decide? Okay, the window size is decided by this particular formula: minimum of receiver window size, congestion window size. So basically, receiver window size, it talks about what is the capacity we have for the receiver. Okay, how much buffer space we have with respect to receiver, that is decided by receiver window. Congestion window is how much capacity we have for the network. Okay, for example, let us say at receiver side, I have the capacity to receive 100 bytes, and the channel whatever we have that has the capacity to send it 10 kilobytes. So when we consider channel capacity is 10 kilobytes and receiver has a capacity of 100 bytes, then when we consider these two things, window size will be minimum of these two things. So we have to select window size of 100 bytes. Okay, because here we have a restriction with respect to receiver. Let us say channel has a capacity of 10 kilobyte, receiver has a capacity of 1 megabyte. In that case, we will be able to transmit only 10 kilobytes because there we have the restriction for channel. Okay, like that we need to consider. Okay, so here we have an issue. We have a problem wherein they are saying like what is the value of receiver window? You see, I doubt if somebody is trying to magnify the screen. What is the value of receiver window for host A if the receiver host B has a buffer size of 5000 bytes and we have 1000 bytes of unprocessed data. Okay. So here we are trying to say like this is the buffer space I have. This is the buffer I have, and the capacity of this buffer is 5000 bytes. Okay, so this is something like we have a bus, let us say, and within bus we have the capacity of 50 seats, but already 10 seats are filled. So how much space we have left over? 40. So similarly here also we have the buffer space of 5000 bytes, but we are saying like we have 1000 bytes of unprocessed data. 1000 bytes of unprocessed data. So when we consider 1000 bytes of unprocessed data, I can have receiver window size. Like whenever receiver is advertising the window size, it has to advertise 4000 only. Because more than 4000 in case if it receives, receiver cannot handle that. Yes or no? So that is what we are considering here. The value of receiver window is 5000 minus 1000, that is 4000. Host B can receive only 4000 bytes of data before overflowing its buffer. Host B advertises its receiver window size as 4000. Okay. So here we are calculating receiver size based on what is the capacity we have and how much unprocessed data we have with respect to receiver. Okay. Then what is the size of window for a host if the value of receiver window size is 3000 and the value of congestion window is 3500. Okay. So here we are saying like the capacity at the receiver size is 3000 and the channel capacity is 3500 bytes. When we have like this, so we need to select minimum of these two values. So obviously we will be telling like the window size is 3000. Okay. Then we have a figure which shows unrealistic example of sliding window. We will see why we are saying unrealistic example. The sender has sent up to 202. Okay, we have sequence numbers. So we are saying that till 202 sequence number we have transmitted. We assume that congestion window size is 20. Okay, but when we consider reality, it will be in thousands of bytes. But for our calculation simplicity with respect to calculation, we are just assuming like congestion window size is just 20. Okay, the receiver has sent acknowledgement till 200. Okay, I have transmitted till 202, but I got acknowledgement till 200 only. Okay, with receiver window size of 9. Okay, this also like when we consider the receiver window size also, in reality this will be thousands of bytes. The size of sender window is minimum of receiver window and congestion window. Okay. So here what they are saying is receiver window size is 9, like RWND value equals to 9 and congestion window size is 20. So obviously we need to go with minimum of these two things. So window size we will be fixing is 9. Okay. We said like bytes 200 to 202 that are already sent because already in the first statement we have set like that, and we have not received acknowledgement. Okay. So by looking at this one, you will be able to understand. See, this is a situation we have till 200. Till 200, I have received. Till 200, I have received acknowledgement, so I don't have those things in my buffer. Okay. Then, what is the window size we are saying? Minimum of 20, 9. Okay, so 9 is the window size. From 200, we will come 200, 1, 202, 203, 204, 205, 206, 207, 208. So when I consider my window size till 208, I'll be able to transmit without any issue. Okay, but what transmitter has done till 202, it has transmitted earlier. Till 202, I have transmitted and I am waiting for acknowledgement. Okay, and what are the bytes which we can transmit without waiting for acknowledgement? What are the sequence numbers which we have within this sliding window? All those things we will be able to send without waiting for acknowledgement. So 203, 204, 205, 206, 207, 209. Okay. So overall, we are saying like till 200 we have received an acknowledgement, and in the acknowledgement we have received the receiver window size as 9. Okay. And network has advertised like it has a capacity to transmit 20 bytes per 20 bytes at a time. So when we consider window size, that is 9. So when we consider what are the bytes which are in the window, they are from 200 till 202. And we have transmitted till 202, and we didn't get any acknowledgement. So we are waiting, we are not removing those things. And next byte which can be transmitted is 203. Okay. Okay, next what happens, the continuation to the previous one, the server receives a packet with an acknowledgement value of 202 and receiver window size of 9. The host already sent bytes 203, 204, 205. The value of condition window is still 20. Okay, so acknowledgement we are receiving till 202. Receiver window size is 9. Condition window size is still 202. 20. So what happens in this case? We received acknowledgement till 202, right? So we have to remove these things. We have to remove these three things because we received acknowledgement till 202. Okay, and still the case is like receiver window size is 9 itself and condition window size is 20. So obviously window size will be 9. So starting from this location, okay, let me change color. Starting from this color, I need to count 9 positions. Okay, 1, 2, 3, 4, 5, 6, 7, and we will have 210 and 211. Till 211, I can include within the window. Okay, that is what we will see now. Okay, sorry. Even nobody pointed out. We got acknowledgement number. What is the number? 202. We got an acknowledgement 202. That means the receiver has accepted till 201. Okay, and it is expecting to receive 202. Okay, so starting position is here, and the ending will be till 210. Okay, and receiver transmitter has already transmitted till 205. Okay, what is the next expected sequence number? Like next byte which we can transmit, that is 206. So without waiting for acknowledgement, we can transmit 206, 207, 208, 209, 210. Okay, so we are just trying to discuss what can be transmitted. Okay, what are the packets which are waiting in the queue? How sliding window is moving? Okay, so previously it was at 200, right? So what happened? Sliding window moved this direction. This closing happened. This side also previously we were at 208 and we moved in this direction. That is opening. Closing done, opening done. Next we have sender receives a packet with acknowledgement value of 206 and receiver window 12. Okay, so till 206 we have received acknowledgement. That means we received acknowledgement till till 205 the receiver has received. Okay, 206 it is expected. Okay, the host has not sent any new bytes. Previously, what was the till what sequence it has transmitted? Till 205 it has transmitted. Now we have received acknowledgement number 206. That means I can remove all these things. Okay, till 205 I'll be able to remove. Okay. We'll see how we can update this window size. Till 205 you can see we have removed. Okay, we have removed from window because they have been acknowledged by receiver. From 206 you can see window size has been increased here because the receiver has told now the window size is not 9 but it is 12. So we are again selecting the minimum of 20, 12. So window size will be 12. From 206 we will count 16 and we are going till this point, till 270. I have not transmitted any data and I need to transmit from 206. So 206 to 270, anything we can transmit without waiting for acknowledgement. Okay, we'll see what happens now. So in the previous one, like the host receives a packet with an acknowledgement 210, and you see what is happening here. Receiver window size is 5. Receiver window size is 5. Acknowledgement is 210. That means we have already transmitted and we received acknowledgement till 209. Okay, so let me go back to the previous one. Okay, what we are saying, we received acknowledgement of 210. That means all these things have been transmitted and we got acknowledgement also. Okay, right, till 209 we got acknowledgement. Previously we said this is my boundary, but what is the receiver window size we are saying? We are saying 5. So the window size will be 5. So starting from here, we need to count 5. 1, 2, 3, 4, 5. Okay, this is where my new closing up window is. Where was the previous one? This is the first one. This is updated one. Okay. So what happened previously? Let us say I have transmitted already till 217, but receiver is saying like you can transmit only 250. That is not acceptable, right? Okay. Previously you have told like till 217 you can transmit, but you are saying now till 214 only you will be able to send. Okay? Like that, this is called closing up. This is called shrinking up window, which is not allowed. Okay. Whenever you advertise new value, you have to make sure like your window, whatever the window you have considered previously, that is not shifting in this direction. Okay, that we have to make sure. Okay, so all the online students, you are able to hear, understand?
Yes, sir.
Yes, sir.
Yes, sir.
Is it clear what is the issue with sliding window protocol?
Yes, sir.
Okay, so let's go with how we can avoid this one. Okay, this is what we talked about. According to new window size, you'll be able to transmit till 214 only, but previous location of window was like this. Okay, so that is the reason we said this is unrealistic example. Okay, initially we said this is one unrealistic example, right? Because this is what we are going to have. Okay. So how can the receiver avoid shrinking of the window in the previous example? That is the question we have. So what we are saying here, see, whenever you are giving new acknowledgement, we need to follow either of these two cases. Okay, both are same. We just moved the parameters towards one side. So whenever you are advertising new acknowledgement value, if it satisfies this particular condition, then we can make sure like shrinking of window is avoided. Okay. So how we are doing? When a new acknowledgement plus new receiver window size should be greater than or equals to last acknowledgement plus last receiver window size. Okay. Let us go back to previous one. So what is the new acknowledgement number now? New acknowledgement plus new receiver window size should be greater than or equals to last or previous acknowledgement number plus last receiver window size we have. Okay, so let us go back and see what are the values we have. Previously it gave acknowledgement till 206 and receiver window size is 12. Okay, so we have 206 plus 12. This side what do we have? New acknowledgement number is 210 and new receiver window size is 5, right? So what is the value? Towards this side we have 215, this side we have 280. So the condition is not satisfied. So I should not go with this value. Or you can see what is the other thing we are writing here. New receiver window size equals to last acknowledgement plus last receiver window size minus new acknowledgement. Okay, so let me go back again. If I have to find what is the optimum value, I need to go with new receiver window size. This will be 218 minus 210. So at least I need to go with new receiver window size of 8. I cannot go with any other value. Okay. Is it clear, everyone?
Yes, sir.
Okay. So in case, for example, you don't have buffer space. Okay, let us say you want to give acknowledgement, but you don't have buffer space. Give acknowledgement, what happens in that case? Syncing of window can happen. Okay, so to avoid that, what can be done is we better wait for having enough space. Or whenever we wait for providing acknowledgement, what happens? You won't be advertising, right? You won't be advertising, and even sender will not be updating anything. It will wait till you provide complete details. Understood what I am saying?
Yes, sir.
Okay, in case you don't have enough space to receive some data, and if it is resulting in shrinking of window, then receiver has to wait till be satisfied with the condition which we told. Okay, when you satisfy that particular condition, then only you should be able to advertise. Okay, before that you should not send any acknowledgement. Okay, so we have some points over here related to TCP sliding window. The size of the window is minimum of receiver window and congestion window that we have been looking at. The source does not have to send full window worth of data. So we are telling like whatever the segment numbers or sequence numbers we have within the window, all those things can be transmitted without waiting for acknowledgement. But that is not mandatory, like you need to send all the bytes. It is up to you. Okay. So for example, in sliding window we have till 220 sequence number, let us say, but if you have transmitted till let us say 212, you can transmit anything from 212 to 220, but not mandatory, like you need to send all the bytes from 212 to 220. That is what we are saying. The window can be opened or closed by receiver, but should not be shut. That is what we have seen with an example. Okay, we can open by providing receiver window size, updated receiver window size. We can close by providing some acknowledgements to existing sequence numbers, but we are not allowed to shrink the particular window. Okay, the destination can send an acknowledgement at any time as long as it does not result in shrinking of window. That's what we have seen. Whenever if it results in shrinking of window, we need to wait till enough buffer space is available. The receiver can temporarily shut down the window. The sender, however, can always send one segment, like a segment with 1 byte without waiting for acknowledgement. Okay, so that means let us say we received an acknowledgement, let us say till 210, okay, and receiver window size it is telling like 0. Okay, receiver window size it has advertised like 0. That means you are not allowed to send any data. But even though you receive something like 0, receiver window size 0, you are allowed to send 1 byte of that. Okay, so we will see that case. So what we are saying is, in case you have some data, but receiver has updated, maybe with an example we can see. Let us say 210, 211, 212, 213. Okay, this is my starting of window. Let us say this is my ending of window. Let us say. Okay, receiver it is telling like acknowledgement number is 240. That means I can remove all these things in the sliding window. And when it is saying new advertisement, new acknowledgement, new receiver window size, it is saying like 0. In this case, it is allowed. This is not considered to be shrinking because at this point, if I say till 213 I have received and receiver window size is 0, I'm not moving this direction. Like I'm staying at the same position, but I'm not shrinking the window. Okay. We can say like we are not opening the window, but we are just being there. So the receiver is advertising like 0. So I should not send any data because we don't have any sequence number waiting in the sliding window. Okay. So in that case, you are not allowed to send the data, but still sender keeps on sending 1 byte of data. Okay. So we saw a particular heading, silly window syndrome. Okay, while we discussed about first slide of this flow control, we had something like silly window syndrome. What is silly window syndrome means? Whenever sender keeps on sending 1 byte, okay, receiver has advertised byte, it has 0 byte capacity, but sender can keep on sending 1 byte. Let us say like sender is keeping on sending 1 byte. What happens with that is 1 byte means TCP header we are going to add. Okay, how many bytes we have TCP header? 20 bytes. Okay, again in network layer we have header that is also 20 bytes minimum. We are talking about minimum. Again when I go to Ethernet we have 18 bytes minimum. Okay, 20, 20, 18. Total how much? 58 bytes extra we are sending to send 1 byte of that. Okay, so transport layer 20 bytes, network layer 20 bytes, data link layer 18 bytes. From application layer we are getting just 1 byte of data. To send this 1 byte of data, overall we are sending 59 bytes. Okay, so are we effectively using the network resource here? We are not using. Okay, so that is the issue we are calling as silly window syndrome. Okay, we have different algorithms to overcome silly window syndrome, but we are not discussing. But in case you are interested, you can look into the textbook. Okay, so as long as part of our syllabus, we are considering how sliding window protocol is working. Okay, and there can be problems also. They can give a statement and they can ask you to find what bytes can be transmitted without waiting for acknowledgement. All those things they can ask. Okay. Next, one more important thing we have in TCP is error control. So when we say error control with respect to TCP, what exactly we are talking about? That is the question. So we might be talking about with respect to detection of corrupted packets. Okay, when we say error control of TCP, we may be talking about detection of corrupted packets. We may be talking about lost packets, and we may be talking about out of order packets. We may be talking about duplicate packets. Okay, any of these things, if you are trying to handle, that is nothing but error control. Okay, so looking at corrupted packets, lost packets, out of order packet, duplicate segments. All these things have to be handled with respect to TCP error control. So the error control in TCP is mainly achieved with the help of checksum, acknowledgement, and timeout values. Okay, how TCP handles error control is with the help of checksum, with the help of sending acknowledgements, and by using the concept of timeout. Okay, these are the three things which we will be using to come up with some error control mechanism in TCP. So in this topic, we will be looking at different topics like checksum. We will be looking at how to calculate checksum. So how to calculate? Same way, like while discussing TCP header, we said, right? We will include pseudo header. We will include all the fields of TCP, and checksum field we will be keeping 0, and we will be calculating checksum. Okay, whatever the total we get, that we will be complementing, and the complemented value we are going to keep in checks. Okay, and at the receiver side, when we recalculate this checksum value, if I receive the value as non-zero entry, then we are going to consider as we have some issue with respect to the data which we have received. In case we don't have any like non-zero entry, the result is 0, then we need to consider that we don't have any error with respect to receiver. So that is what we will be considering with respect to checksum. Apart from that, we will see how acknowledgement will help us in handling error. Okay, error in the sense, it's not only with respect to corrupted packet, but it can be with respect to how last acknowledgement is handled, or how last segment is handled. When we receive out of order packets, how TCP responds to that with acknowledgement. When we receive duplicate packets, how TCP responds. These are some of the things which we look. So here we also talk about retransmission that is done with the help of timeout value. Retransmission timeout. Then we have some scenarios. We will see how to handle those things. Okay. So here it's not like whenever you are interested in sending some data, sending some acknowledgement, here sending. It's not like that. Okay. We have some set of rules for generating acknowledgements. Okay. So whenever you receive data, simply we are not transmitting the acknowledgement. Okay. Whenever receiver receives data, simply it is not sending the acknowledgement, but the receiver generates acknowledgement based on some rules. What is the first rule is, whenever you want to send some data, along with data you are going to attach acknowledgement. Okay. Even in data link layer we discussed this concept. This is called as piggyback. Why we need to go with this one is acknowledgement. If I have to send only 1 byte, right? Okay. Only to see acknowledgement number is, let us say, 4 byte, and acknowledgement flag is 1 byte. Just to send this particular information, all the day you will be wasting 58 bytes of data overhead. So what we thought is, instead of sending acknowledgement alone, let us do like attach this one with data in case you have some data to be transferred. Okay. So along with data we are going to send. When one end sends data segment to other end, it must include an acknowledgement. Okay. That gives next expected sequence number. Okay. So basically we are just saying that whenever you are sending data, if you have some acknowledgement to be transmitted, attach that acknowledgement along with data and send. Okay. So that is the first rule which we have. Okay. Second rule is, let us say server has received a segment. Okay. And basically after receiving you need to send an acknowledgement, right? But what second rule says is, in case you have some acknowledgement to be transmitted and only 1 segment you have received, then you should not send acknowledgement. Okay. So buffer, we have buffer, right? Let us say within the buffer, I have only 209. I received only 209 segment number. Okay. After receiving 209, immediately I should not send acknowledgement. I have to wait until 500 milliseconds or another segment arrives. Okay. Before you send acknowledgement for 209, the condition is you need to wait till you receive 210, or after receiving 209, I am about to cross 500 milliseconds. My point. So we are saying like delay sending the acknowledgement at receiver side till you receive a segment or 500 milliseconds. That means I need to wait till 2 segments are received or 500 milliseconds time. Okay. Online, you are able to understand what I am saying?
Yes, sir.
Okay. So we should not send immediately an acknowledgement after receiving single segment, but we have to wait till you get at least 2 segments. Okay. Whenever you receive 2 segments, we can send. Or let us say that is the last segment which I am getting from client side. I won't be having second segment. So I need to wait 500 milliseconds before I transfer acknowledgement. Okay. But this is an exception. In case you have data, in case you have some data to be transmitted, immediately after receiving 209, you will be able to send. But whenever you don't have any data, this is the case. Understood? Okay. Whenever we don't have any data to be transmitted from server to client, and I have only one segment which I have received, then I need to wait for another segment or 500 milliseconds. But in case I have data, I can do piggyback. Okay. So, like everything, all the rules which we are saying, they are interlinked. The third rule is interlinked with second one. There should not be more than 2 in-order unacknowledgement segment at any time. It prevents unnecessary retransfer. What we are saying here is, let us say 209 I have received, next 210 also I have received. So I have received 2 ordered packets. Okay, that's what we are saying. 2 in order, and I have not provided acknowledgement, unacknowledged segments. Okay, whenever I have 2 in order unacknowledged segments, immediately I need to send acknowledgement. Okay, in this case, we are overcoming the thing of 500 milliseconds. Previously, we said we need to wait 500 milliseconds and we need to wait for one more segment to arrive. But what we are saying, if I have 2 segments in order unacknowledged segments, immediately you need to send acknowledgement. Okay, that is the exception with respect to second one. Okay, like when we actually see a scenario, you will understand more. When a segment arrives with an out of order sequence number that is higher than expected, the receiver immediately sends an acknowledgement announcing the sequence number of the next expected segment. Okay, let us say I have received 209, 210 I have received. Okay, I am supposed to receive 211, but what happened? 212 I have received. Okay, I have received 212. In that case, what receiver does is, I am expecting 211, but what I have received is 212. So immediately it sends an acknowledgement telling like I am expecting 211. Okay. So that is a fourth rule which talks about fast retransmission. Okay. Next, when a missing segment arrives, the receiver sends an acknowledgement to announce the next sequence number. Okay. The previous thing is about out of order sequence number. Whenever you receive out of order segment, you will need to send an acknowledgement. Let us say we are waiting for 211, right? In future, let us say I received 211. 212 also I have. So I need to send an acknowledgement telling like I have received whatever the missing segment was. Okay. Then let us say I have not advertised about 211 or 212. Okay. Sender has retransmitted that because of timeout. In that case, we will be receiving 2 times this 212. Right? In that case, we just need to discard that and immediately send an acknowledgement telling what is the expected sequence. Okay. So these are the rules we have with respect to acknowledgement. Okay. This we have seen. Acknowledgement does not consume a sequence number, and even we don't provide any acknowledgement for acknowledgement. Okay. Acknowledgement you are sending to the other side. Other side will not send another acknowledgement to this acknowledgement. Only for data and control messages we will be sending acknowledgement. Okay. So we have 2 types of acknowledgement here. Accumulative acknowledgement, that is what which we are using in TCP. Accumulative acknowledgement is receiver advertises next byte it expects to receive, ignoring all segments received out of order. Okay, I may be having out of order packets, but receiver talks about within the order what is the next expected sequence number which I am supposed to receive. Only about that it will be advertising. This sometimes referred to as positive acknowledgement. So it is just telling positive information. It's not telling about any missing packet. It is not telling about any duplicate packets. Okay, it is not telling about any out of order packets. Only positive information. This is safe. In case we have lost packet or duplicated packet or discard segment that are not reported with respect to accumulative acknowledgement. Next, we have selective acknowledgement, or we call it as SACK. SACK, SACK, selective acknowledgement. In this one, this is not for replacing acknowledgement, but it also reports some additional information along with whatever the information which we provided in accumulative acknowledgement. Okay, in accumulative acknowledgement, what we are saying, what is the next expected sequence? In selective acknowledgement, what we are doing is, along with accumulative, like the sequence number which we are expecting, we are saying in case if I have any duplicate packets, we are saying in case if I have any in order, out of order packets. So all those things we are providing in this particular selective acknowledgement. Okay, but you need to remember, we are not implementing selective acknowledgement as part of TCP, but this is implemented as part of SCTP. In SCTP, selective acknowledgement concept will be there. In TCP, only acknowledgement concept will be there. Okay. Retransmission after RTO. Okay, whenever retransmission timeout happens, how we are retransmitting. Okay, basically, whenever you send any particular segment, you are going to set a timer. Okay, let us say the round trip time, the amount of time it takes for you to travel to the other side and acknowledgement to come back, that is called round trip time. If we consider round trip time is something like, let us say 20 milliseconds, then we will keep RTO timer based on that value. Okay, we are going to wait till that particular time. In case if I receive acknowledgement within that particular time, I don't have to do anything. I'll go with next segment. But in case within my RTO timeout, retransmission timeout expires, if I don't get acknowledgement, I need to consider like the segment is lost or the acknowledgement is lost. So I will be retransmitting that particular segment. Okay, that is the importance of retransmission after RTO. Next, we have another case, retransmission after 3 duplicate acknowledgements. Let us say, like whenever there is some missing packet with respect to receiver side, even in the lab also we consider this. Okay, I sent first one, I received. Second one I sent, but last in the middle, I sent third one, fourth one, fifth one. What happens here is, whenever you send first one, the other side, it is going to respond with acknowledgement. It sends an acknowledgement with acknowledgement number 2. Basically, it expects 2, right? Sequence number 2. Okay. Whenever it receives 3, basically it is expecting 2, right? But I received 3. Okay. I received 1. I received 1. I didn't receive 2. I received 3. I received 4. I received 5. Immediately after receiving 3, what is the rule? Whenever you receive any out of order packet, immediately you need to send acknowledgement. Telling what is the next expected number. What is the next expected number? 2. So immediately here we are saying 2 we are expecting. Again here also you send 2 we are expecting. Again here we are saying 2 we are expecting. So this is the original acknowledgement which we are supposed to get for 2, and these 3 are duplicate acknowledgements. So as soon as I receive 3 duplicate acknowledgements, immediately I need to retransmit second segment. Okay. Even while discussing condition control of TCP, we discussed this, right? So the same thing. No retransmission timer is set for an acknowledgement segment. Only for data segments we are going to have this retransmission timer. Data may arrive out of order and temporarily stored by receiving TCP, but TCP guarantees that while delivering to the process, application process, it is not going to send out of order packets. In order packets only, it is going to send to the application process. Okay, that is what we need to consider. Okay, now we look with respect to example with respect to each and every rule. Okay, so what is the first rule says? Whenever you are sending data, you need to attach an acknowledgement for that. Okay, that is what we are doing here. Using rule 1, whenever you are sending data, you are attaching an acknowledgement. That is piggybacking mechanism, and that's it. So this side again it is sending a segment. Okay, so when I consider here, I have only one segment. One segment I have received. Okay, so I'm not sending an acknowledgement, but I'm waiting till 500 milliseconds completes. Okay, you can see here we are waiting till completion of 500 milliseconds. What rule 2 says? Whenever you receive an acknowledgement, you have to wait for one more acknowledgement. Whenever you receive some data, one segment of data, and in case you don't have any other data segment pending in your buffer for acknowledgement, you should not send acknowledgement. You have to wait for one more segment, or you need to wait at least 500 milliseconds. So whenever 500 milliseconds complete, immediately we are sending an acknowledgement. In this case, I don't have any data to be transmitted. In case I had some data to be transmitted, I would have attached data along with acknowledgement. I can transmit immediately. Okay, data plus acknowledgement means I can send immediately, but I don't have this data. Okay, when I don't have data, I need to wait 500 milliseconds. Okay, okay, acknowledgement is received. Then the other side is sending another segment. Again, I am looking for 500 milliseconds, but immediately I got one more segment. Okay, I am overcoming or removing the concept of 500 milliseconds, and by using rule 3, which says whenever I have two in-ordered segments waiting in the buffer for sending acknowledgement, immediately I need to send acknowledgement. Okay, when I consider here 5,000 to 6,000 I have, and 6,000 to 7,000, two in-ordered segments I have in the buffer. Okay, I should not wait 500 milliseconds in this case. That is the reason we are describing here. Before 500 milliseconds completed, I was having two segments for sending acknowledgement. So immediately I'm sending acknowledgement. That is by using rule 3. Then, whenever we are sending a particular sequence, we are starting retransmission time. Okay, this is last in the middle. I send 801 to 900. Okay, basically what is happening here? We have a gap here. Okay, whenever out of order packet is coming, what we need to send? According to rule, immediately you need to send acknowledgement telling what is the expected sequence. I received from 801 to 900, but I am expecting 701. Okay, so I am sending an acknowledgement telling I am expecting 701. But from the other side, I don't have anything to transfer. From server side also, I don't have anything to transfer. So what we are doing, we have some retransmission timeout set, right? Whenever that expires, we are going to retransmit that particular segment. And using rule 5, I received out of order packet or missing packet I have received. Okay, this was missing 701 to 800. And previously I got 801 and 900. So till 900 I have all the data without any issue. So I am sending an acknowledgement with 901. Okay, that is by using rule 5. Okay.
Excuse me, sir.
Yes.
Sir, actually, AWP students are having class at Simpson. Like
Okay.
from 10.
We will close in 2 minutes. Okay. So the receiver TCP delivers only ordered data to the process. Okay. The last rule, 6th rule, we will see next class then.